So in our interest formulas, we have been given things like A or P or R and N and T, but and depending on which letters we were given, we could solve for the other ones. But the ones that we can't solve for is the one in the exponent. We can't solve for that T, at least not yet. So in order to do that, we're going to need logarithmic functions. So let's learn about what logarithms are. You probably have heard of logarithms, or hopefully you've heard of them. But this should just be just hopefully a fresh way of looking at it, and hopefully you'll understand them this time around if you don't already. So the way I want us to think about logarithms, we have to think about inverse functions or inverse operations. So let's think about how we use other functions that we're already familiar with to solve, right? So say you're solving x plus 5 equals 3. The fact that we are adding 3 to this x, we needed to sort of undo it, right? We want to come up with the inverse operation of that. So we subtract 3, and as long as we subtract 3 from both sides of the equation, it's still an equation, and the positive 3 and the negative 3 are canceled, right? It's sort of a zero pair, and we just get x equals 2, right? Or if we were subtracting, so say we started with x minus 3 equals 5, then to undo subtracting, we would have added 3 to both sides. So we already know that addition and subtraction are inverse operations of each other, right? Likewise, multiplication and division are inverse operations, right? So if we have 3 times x, we just divide. So I'm not going to belabor this point here. Let's get to slightly more advanced functions. Well, what if we're cubing something? How do we undo cubing? Well, we have this symbol, cube root, and at one point in your life, this was a very intimidating symbol, and you were like, what is this, right? But you eventually just learned to get comfortable with it, and you said, okay, I get that cube root just means that undoes cubing, right? And actually, if we'd started with the cube root of x equals 5, cubing it would have been the way to cancel out that cube root. So cube root and cubing are inverse operations of each other, just like addition and subtraction are. They cancel each other out, and it doesn't matter if I cube first and then cube root, or cube root and then cube. They just cancel each other out, right? So, but what if we have the variable being in the exponent? So here's our new idea. So how do we solve 3 to the x equals 5, right? This is the new thing. How do I get this x by itself? We need a new kind of operation. We need something that undoes exponential base 3. So we introduce a new symbol, and I'll admit that it is a somewhat intimidating symbol, just like the cube root was at some point in your life, but it's just log subscript 3, and it stands for logarithm base 3. Okay, and the 3 is a subscript. It's the base subscript, sorry. It is the base of the logarithm. And some people say because it's down and as a subscript, you can think of it as like in the basement. It's the base. But it's a symbol, log base 3 of 3 to the x, that is the inverse operation of 3 to the x. So it cancels out that base 3 and gets it to a regular x on its own. But you can't just take log base 3 of the left side. You have to also take log base 3 of the right side. So what value of x, when I take 3 to that number, do I get 5? And the answer is whatever log base 3 of 5 is. Okay, so just like I was saying before, the order in which you do this doesn't matter. Log base 3 of 3 to the x, those we're going to cancel. But also, if you started with a logarithm and you wanted to undo it, you would just do 3 to the log base 3 of x, right? Both of these are inverses of each other. So whether it's log of the exponential or exponential to the log power, those are inverse operations of each other. They're going to cancel each other out. Okay, now you could spend a decent amount of time on logarithms, and we're really just using them for the sake of solving for that exponent, solving for that t. So we don't need to worry too much about all the logarithm properties and a bunch of other things that we could spend weeks on. We're really just going to learn, we really just want to talk about how do we do things like how do I evaluate log base 3 of 5? Okay, so I'm linking here a free logarithm calculator, or you could just Google one. I'm sure you could come up with something. And you just want one that you can enter in the base, and you can enter in what number you want to take the logarithm of, and it'll evaluate it for you. So I'm going to tell you that if you do log base 3 of 5, you should get 1.46497, let's say. So find a calculator, try it out, and make sure you know how to evaluate logarithms of any base. But let's make sure this number makes sense. Remember that this answer was the exponent that we raise 3 to. So 3 to the 1.46497 power is supposed to be giving me basically 5. And I'm putting approximately equal to because I did round a little bit. So this is just about what it's equal to. And does this make sense? Does it make sense that 3 raised to about 1½ power would give me 5? And the answer is sure, because 3 to the first power is just 3. But if I go 3 to the second power, that's 9. So 3 to the 1½ should be somewhere between 3 and 9. So anytime you're using these calculators, make sure your answer seems reasonable. Okay? But just to summarize what we just said here, for these logarithms, really I want to just think of these as inverse functions of exponentials. So log base b of b to the x, those log base b and the b exponential will cancel and just give us x. But also if I had b to the log base b power, those are going to cancel, right? So think in your head about like how cube root of x cubed, that would just give you x, or x cubed. If I, sorry, I got to do the other way around. Do it the other way around. So we want to start with the cube root of x, then cubed. That would still give us x, right? Both ways give you just back to the original function. Both ways for logarithms give you back to the original function. There are 2 special logarithms that we just want to make note of. If it's base 10, we call it the common logarithm, and people get lazy and just write it as log x. So the subscript is omitted. Kind of like with square roots, we don't write the 2 there, right? We just think of that as a square root. So we get lazy with square roots, we get lazy with logarithms. Base 10, we don't write the 10. Another common logarithm, I shouldn't say common, another useful one is the natural logarithm. That's that log base e. Remember, we already talked about e being the natural base. So because it's the natural logarithm, and because people who were using logarithms first were using Latin, they called it Logarithmus Naturale, or however you pronounce that. So it was ln instead of nl. So we abbreviate it ln of x. That stands for the natural log of x. So when you see ln of x, think to yourself, oh, that's just log base e of x. Okay?